Hi guys, let us see multi-stage graph problem using dynamic programming. So what is the problem statement for multi-stage graph problem? A multi-stage graph is a directed graph in which nodes are separated into stages and all edges are only from one stage to the next stage. So the goal of multi-stage graph problem is to find the minimum cost from the source node to destination node. Let us try to understand the multi-stage graph. As we have discussed earlier, the nodes are separated into stages. We can see in this diagram, the nodes are separated as stage 1, stage 2, stage 3 and stage 4. So stage 1 contains node A, stage 2 contains B, C, D and stage 3 contains E, F, G and stage 4 contains H. And also each edge connects a node from one stage to next stage. That means the nodes are in stage 1 is connected with the nodes in stage 2. Nodes in stage 2 connects with the nodes in stage 3. Like that, nodes in stage 3 are connected with the nodes in stage 4. No edge connects the nodes in the same stage itself. That you can observe in this diagram. That is what we call it as a multi-stage graph. Here, what is the problem? We want to find the minimum cost from source node A, that is stage 1, to the destination node H in stage 4. For this problem, there are two approaches. One is backward approach, another one is forward approach. Let us start with the backward approach. In this backward approach, we start with the source vertex in stage 1 and we see the edges from stage 1 to stage 2. That means A to B, A to C and A to D. So you add this distance of this edge 1 plus then stage 2 to stage 4, that is B to H. Then A to C is 1, so 1 plus distance of C to stage 4 H. Then 4, that is A to D is 4, 4 plus distance of D to H. So we consider this as equation 1. Now let us consider the distance from stage 2 to stage 4. That is, in stage 2 there are three nodes B, C, D. So B to H, C to H and D to H. So D of B to H is equal to, there are two edges which connects from stage 2 to stage 3 from the node B. One is with weight 5, that is B to E, that is 5 plus distance of E to H. The another one is with weight 2, so 2 plus distance of F to H. Like that, if we take from C to H, one edge is with weight 7, so minimum of 7 plus distance of E to H. The another one is with weight 3, so 3 plus distance of F to H. Like that, for D, 6 plus distance of F to H. Another one is 4 plus distance of G to H. So keep the equations as 2, 3 and 4. Now consider the distance from stage 3 to stage 4. That is, stage 4 is the destination node. So here you have got only one edge which connects from stage 3 node E to H. So there is no concept of minimum here. So distance of E to H is 3. Like that, F in stage 3 is connected with only one edge to H. So D of F to H is equal to 4 and D of G to H is equal to 5. And remember that suppose if the graph has got 5 stage something like that, then we have to do the similar process what you have done in the previous stage 2 to stage 3. But now this graph has got only 4 stages, so we have come to the final stage, that is d of e to h is 3, d of f to h is 4, d of g to h is 5. Now substitute these values in the equation 2, 3 and 4. Substitute the values of e to h, f to h and g to h in the equation 2, 3, 4. For the reference, I have given the 2, 3, 4 here. So you substitute the values of d of e to h, d of f to h and d of g to h. So when you substitute the values, for example, d of b to h is equal to minimum of 5 plus d of e to h is 3 and 2 plus d of f to h is 4. So out of this, the minimum is 6. Like that, d of c to h, so here 7 plus d of e to h is 3, 3 plus d of f to h is 4, the minimum is 7. Like that, d of d to h, substitute the values of f to h and g to h in this equation, so the minimum is 9. So now you got the values for distance of b to h and distance of c to h and distance of d to h, and the values are minimum. So now you substitute these values in equation 1. Now we are substituting the values of distance of b to h, distance of c to h and distance of d to h, which we have calculated earlier, in the equation 1. So you refer the equation 1. Here you substitute the values of distance of b to h 6, distance of c to h 7, distance of d to h 9. So when you calculate minimum of these values, you got 7. So where you got the value 7? Here, that is 1 plus distance of b to h. So the final answer is a to b. Then b to h, how did we get 6? That is b to f, then f to h. So the final answer is a to b, b to f, then f to h. The minimum cost is 7. So this is the way you have to calculate the minimum cost from source node to destination node using backward approach in multi-stage graph. Now let us try to find the solution for multi-stage graph using forward approach. Previously we have solved this multi-stage problem using backward approach. Now we are going to do with the forward approach. So the problem is to find the minimum cost from source node A to destination node H. That means source node A in stage 1 and destination node H in stage 4. First step in this forward approach is to find the edges from stage 1 to stage 2. So here distance of A to B 1 and distance of A to C 1 and distance of A to D 4. So we find the edges from stage 1 to stage 2. Next step is to find the ways to reach from stage 1 to stage 3. So in stage 3 there are 3 nodes E, F, G. So you find the distance between A to E. So distance of A to E. So minimum of, what are the ways to reach from A to E? A to B, then B to E. That is 1 plus distance of B to E. Another way is A to C plus distance of C to E. So out of these two, the minimum is 6. So like that, you take the next A to F. So for A to F, A to B, then B to F. That is 1 plus distance of B to F. Another one is A to C, then C to F. That is 1 plus 3. Another way is A to D, then D to F. So that is 4 plus 6. So out of these 3 values, the minimum is 3. The next is A to G. So for A to G, there is only one way, A to D, D to G. So the value is 8. In this forward approach, first we saw the path from stage 1 to stage 2. That means stage 1 there is only one node A, and stage 2 there are 3 nodes B, C, D. So we found the distance from A to B, A to C and A to D. Then we saw the path from source node in stage 1, that is A, to the nodes in stage 3, that means A to E, A to F and A to G. So for all the path from A to E and A to F and A to G, we calculated the minimum weight. Now we want to find the path from source node to destination node, that is stage 1 to stage 4. So distance of A to H is equal to minimum of distance of A to E, which we already calculated, that is 6, plus distance of E to H is 3. Like that, distance of A to F, which we already calculated as minimum value 3, and distance of F to H is 4. And distance of A to G, we already calculated as 8, then G to H is 5. So out of these 3, the minimum value is 7. The 7 we got it from the middle one, that is distance of A to F, then distance of F to H. So distance of A to F, how we have reached the minimum, that is A to B and B to F. So the final answer is A to B, B to F, then F to H. So the total cost is 7. So this is the way we calculate the minimum cost in multi-stage graph using forward approach.